You think a deleted file is gone, wiped, erased, forgotten. But here is the truth. In Git, nothing ever really disappears. That config with an API key a dev cleaned up, that private cert they swore they removed, it's still there. Period in the history, waiting, and if you know where to look, you can bring it back. That's why I call TrashCash, because what looks like garbage, old commits, deleted files, dead history, can actually be the most valuable thing in the repo. Today, I will show you how trash becomes a treasure. So, this is AmrSec, go get your coffee ready, and let's dive in.
The channel has enough content.
As this is
A while back, I got tired of the same checklist. XSS, SQLi, SSRF, IDORs, same cycle, same noise. So I went deeper, not into new payloads, but into Git itself. Blobs, trees, commits, reflogs, the plumbing most people skip. And that's when it clicked. The real leaks were not in the code you could see. They were in the files people thought they deleted. Midnight fixes, accidental pushes, rush to commits. Developers hide the evidence, but Git never forgets. That's a trash cache, and if you know how to dig, this trash turns into high-impact bugs, serious payouts, and real breaches. So what are we doing here? It's simple. We are going to dig into Git history, not just to find secret, but to restore deleted files and see what hidden inside. Think of it as digital dumpster diving, except this trash can hold gold. API keys, tokens, configs, private source, and so much more. By the end of this video, you will understand exactly why deleted history is dangerous, how to restore it safely, and how to triage what you find without ever misusing it. That's the plan. Short, repeatable, and dangerous if you just ignored it. So basically, before we dive into this, the first thing we need is a source code program, okay? So we can find the thousands of them, whether it's in HackerOne, Bugcrowd, Integrity, Yes We Hack, they all have source code programs. So what we are going to do is we're going basically to go to Yes We Hack, okay? And before I get into the programs, I want to mention something that recently Yes We Hack just published a really nice article about race conditions. It is right here. It's really nice. You have to check it out, okay? So that's it. Let me get back to the programs. Right here we have the Yes We Hack programs. And we have to choose the scope to be other because there is no source code, and other means hardware or source code or whatever. So this is exactly what we need. After that, you will see that we have a lot of programs right here. Actually, there is a program called OnCloud already have a source code, a target. We can just start working on it, which is here. So if I scroll a little bit down, you will see that right here we have GitHub repos, and all of them are in this code. So let me pause here for a second. Why Yes We Hack? Because Yes We Hack is like super fast. If I just found a bug right now and reported it, by tomorrow I will be having a response, whether it is accepted and they rewarded me, or just false positive, or they rejected it, or whatever it is. But I will just get a quick response, so I can continue. I will not wait for a week or something like this. So this is really important. So right here, if you take a look on the scope, you will see that GitHub/OnCloud, and you will here notice something that we don't have all the organization in the scope. And what I mean with this is, if I open this in a new tab right here, you will see that OnCloud itself is organization that have 173 repositories, but not all of them in the scope, because if it was all of it in the scope, by using a simple script, we can just clone all the repositories. But we can do this because they have a specific repositories right here in the scope. So right here, I will just go to my terminal. I will make a new directory called for example, OnCloud, and I will get into OnCloud. And right here, I will make another directory. Let me zoom for you. And I will call it source, okay? So I will clone all the repositories and get back to you. Alright, so as you can see, I'm here. I just cloned 5 repositories. So let me make this easier for you. Let's say that all the organization is not in the scope and you need to clone all these repos. What you have to do is simple. Just copy all of them, paste them in a text file or whatever. Just use xargs to clone each one, and you can just do this in 2 minutes and this all will be cloned. Okay, so this will be easier. So basically right here we have all the repositories, and this our first step. We have to clone all of them locally. Okay, after this we have to choose which one we're going to work on. So let's say that the first thing we want to get into is core. Let me zoom a little bit for you, and we're going to get into core, and after this I will just list the files so we can see right here. Let me just ls-lah. All right, so basically right here we have .get, .github, .getignore, .htaccess, and all these data. This is exactly what we want. So I will clear this, and here what we want to do exactly. We're going to run get log -def -filter equals d. So it's going to filter for the files that's being deleted, -summary, and after this we're going to grep only for delete. Once we run this here, okay, so this is a little bit too long for this repo, but let me just wait for it to finish. Let me zoom out. Okay, so basically as you can see right here, it's giving me a warning that skipped because there is too many files, which is really weird because like I don't know why this too much files are being deleted. So right here this looks like I don't know, like an update, so they deleted all the files or something like this. So let me just choose another directory, which will be, for example, let's say client and clear, and let me do the same right here. I just don't want this to be confusing. Right here we have list files. As you can see, we have these docs, we have the GUI, and we have this CBB files. So basically they are all just normal files. We're going to pick a suspicious file. For example, all these files looks really normal. So right here we have this checksync, the C file. We have this config file, which is a little bit suspicious, but not really suspicious. All the other files looks really normal, such as basically PNG files. So this is good. We have the CBB files. So let me scroll a little bit down until we see something that looks suspicious. Right here, nothing looks suspicious, but let me take this config file as an example. So we're going to do this, and also we're going to grep for conf. Okay, so that's what we need. Okay, right here, let's talk about this file, for example. It's not suspicious at all in this case, but it's just an example. So we have delete mood and this hash after this file. So now it's time to get more context about the deletion, commit messages and files are changing and so on. So right here we're going to do get log -different -filter equals d and the state -- and after this we're going to give it the file path. And once I hit enter, right here you will see nothing. So let me try with other file. So let me get this file, for example, and all right. So as you can see right here, we have this commit. It's only one commit and the author of it and so on. So the thing here is I want you to understand what's happening. We are not trying to find something right here. I'm just telling you how you can do it. So let's talk about this file, for example. Or we can also choose another file that have multiple commits, such as this one, for example. I think it will have multiple commits. Let me try this with you. All right, so it's still one commit, whatever. So focus here and focus really well. Let's say that this file is super suspicious and we saw that this commit, for example, is rushed the commit and we need to get back this file. So here's what's gonna happen. We're going to get checkout, and after this we will have to add the hash of the comment. So this hash, for example, and after this we will add like this. After this -- and the path have to match, so it have to be the same path, and once I hit enter it will be restored. So if I cat this file right now, which was deleted, I will see that I have it right now here. So this is cool. Right now let's understand what's happened. First we have cloned all the repos. Okay, after this we got into one repo, for example, and start to check for all the deleted files. Once we did this, We just found a suspicious file and we restored it to get the sensitive data from it. But until now, this is really nice, but this will take too much time from us. I was doing this last week and it was just a small source code target, and it took for me like 1 or 2 days just investigating this. So actually, when I was doing this, I thought, why I just do this when I can just go and hunt for web app target, and in 4 or 3 hours I can get like something critical or high. And that's when I did this. And that's why I have added all the repos in one folder, because actually I have created a script to automate all these things for me, so I can hunt on web applications. At the same time, my VBS is working and hunting for source code too. Let me make this way more clear for you. So right here, we know what we are doing. We are checking all the deleted files, and if there is something suspicious, we restoring it, and we will just start finding what we want, right? So this is cool. Let me clear this right here and tell you something. So basically, these repos are nothing, because as you can see on the target, we have like 20 or 30 repos, and this exactly is still nothing, because there is like other targets that have all the org in the scope. So we need an automation for this. So actually I have this something really special for me, and actually gives me what I really need only. So if I just cp the root script to be here and the nano this script. So actually this script is really basic script. I will not share this with you. What I mean is I will not give it to you as a ready script. It's not a tool, it's just a script I have made to save more time for me. So here is what's doing. Basically, it's just getting a directory and a finding directory and a config for notify. And after this, it just doing exactly what I just did, but in all the repositories. So it gets into the source directory, and let's say that the source directory have like 100 repository. So it will check all of them one by one, and it will grab for really sensitive things I have added by some regex matches. So let me scroll right here. As you can see, we are searching for API keys, access keys, AWS passwords or GWT tokens, private things or database connections. And if I scroll a little bit right here, you will see that I have added some rules to search for base64 encoded data. If you just think for a minute, why should I do this? You will see that it is not useful, but you are wrong, because the developers think that when they encode something in base64 data, they are smart and we cannot get this data. But it's basically, it's nothing, man, base64. And last week I was testing on a target that was end-to-end encrypted, and I found the private key and secret key encrypted in base64 in the source code. So this was something massive actually. So if you know Bash, you will know that this is actually some basic for loops. But if you don't know Bash, this is good. It's your chance to start learning Bash for purpose. So let me run this script with you and tell you exactly what it does. So right here, I will change this directory to be on cloud, and the same here. All right, on cloud, and I will just save this and go out. So as you can see right here, we have the script in the source folder. So I will just move it to be in the main directory. Right here we have the script and we have the source. Watch this. I will clear the screen, change it to be exploitable, all right, and clear the screen, and I won't run it. So if I just run this, you will see that it is starting the secret scan, the fast scan. So this actually script goes to 3 scans. First is just a fast scan to check everything. After this, a really deep scan. After this, a travel hook scan, which trying to find some data and verify it. So right here, you will see that it started the secret scan and the processing the repository, which is custom groups. It's one of these repositories inside. And after this, it starts to search for all the things that we want and the patterns and so on. And after this right here, started the deep pattern scan, and it found 11 potential generic secrets based on rules I have added in the script. So right here is going to run travel hook, and it will just do a comprehensive travel hook scan for this repo. And I want to show you something. This 3 scans runs on each repository, which is awesome. And once it finds something, this data, which is the result, it just sent it to me to my Discord using Notify. So let me just stop this right here, and let me just make this runs fast to show you what I want. So I will go to source right here, and let me rm-r and all, and I will do the same with R. Okay, so I did this so I can just keep one repo so this can go a little bit faster, because right now it's taking too much time. And once I do this, it will just continue. And alright, so it's continuing right here. I need you to take a look on something. So basically right here you will see that it's collecting files to restore, but it's not restoring all the details. It restores the files based on some conditions I have added. So if this file ends with DB, for example, or PK12 or something like this, only it will restore it, because there is a repositories that have massive numbers of files that could just make our storage go out really soon. So right here you will see in the final summary, it's told me that it found like base64's config files, passwords, base64, and guest and passwords. So okay, so basically these finding from the other one. So let me just cat this file, for example, right here, and cat the config files also. And you will see once we catted the config files, we have the sonar-project.properties, or this one, which is tests acceptance config. So we are not really interested in this one, so we can go with the sonar project properties. So when I get into source and ls guests, and we can here cat this file. So from here you will see that this is a configuration file, and from here you may see something interesting. So yeah, that's pretty much it. We restored all the deleted files, and actually you think that because we did not get anything, you think that this is just nothing, but you are wrong, because by using this method I have found the private and public keys, I have found a SSL certifications, I have found a ton of things that you cannot even imagine it is there. Quick recap, we cloned the repos, listed deleted files, restored them, and saw how much trash was still sitting in the history. This is not trivia, this is impact. Every deleted file is a chance to find something that developers thought was gone. And if you can spot it, triage it, and report it, you are turning trash into real world cash. That's a trash cash. Dirty work, big payoff. So, if you found this useful, do not forget to like, subscribe, and hit that bell icon for more cybersecurity content. And if you have any questions, feel free to drop them in the comments below, or you can reach me directly on Twitter. Until next time, stay curious and stay secure.
I think the girls with their nails done now.